There's something that's referred to as in the Osborne-Rubinstein book, attention effect. I've also heard it called the attraction effect, the decoy effect, or the asymmetrically dominated choice. And they present so what I've asked you to do is to try to formally depict such a choice function, maybe in general terms if possible. So I'll give you the example, and then I ask you to look up some evidence for this, and then ask whether it can be rationalized by a preference relation. Is this choice function rationalizable by a preference relation? Okay, so the example they give in section 2.61, they talk about someone who has the following choice, they talk about the answers people gave on their website that they want you to try these things out on to see whether you yourself are quote unquote vulnerable to this bias or just have this following choice procedure, which happens to not be rationalizable by a preference relation. Now, by the way, if I put as one of the characteristics of the good, if one of the characteristics of the good is, if one of the characteristics of the bundle is defined as is the choice set that it's in, then yeah, pretty much everything will be rationalizable. But we're not considering that, okay? Because that would seem to be a bit trivial. So there's a camera with rating A. The camera. They said, which of the following cameras do you choose? There's a camera each camera has two characteristics: an average rating and a number of megapixels. So that's how much, I guess, how much how much it can capture in terms of, actually I don't know, how much it can capture in each shot, the megapixels of the camera. Okay, so people are asked to make the choice first between camera with an average rating of 9.1 and 6 megapixels. They call this camera A. Then camera B, they're asked to choose between A and B. Camera A has a rating of 9.1 and 6 megapixels, and camera 2 has a rating of 8.3 and 9 megapixels. Okay, what do people choose? Well, at least when they last updated this, apparently people chose these about evenly. The last thing they said was 48% and 52%. Okay, so looks like the choice that comes out of the set A, B, or their choice function maps from A, B to, well, sometimes A, sometimes B. Some people have a choice function that maps to A, and others to a choice function that maps to B. Okay, now we have another choice that people were independently presented with, so I guess in some other part of the survey, or some would be presented with one first and some with the other first, or some only with one and some only with the other. Because if I present you these side by side, then if I present you A and B and then I present A, B, and C, that itself is going to affect your choice. Okay, so when you present people with A and B, they choose them about evenly. But when you present them with A, B, and C, with the choice set A, B, C. Now A and B are as above. 9.1 and 6, 8.3 and 4, and then finally 8.1 and 7. For ratings and megapixels. The choices were in their survey were about 30% for A, 68% for B, and 2% for C. Okay, so B seemed to be, for a lot of people, B seemed to be the choice here. So for a lot of people, the choice set A, B, and C mapped their choice function. When they had this choice set, was the choice function, the function of A, B, and C, for many people was to choose B. And presumably, some of the same people who chose B in this choice set would have chosen, in fact, A in this choice set. Okay? So you don't necessarily present them side by side, although you could present them separated over time, and then we could see some of these reversals even among individuals. But if we just presented it to separate populations, we could make some inference that if these were just separate populations, some of the people in this group necessarily, had they been presented with AB, would have had to fall into this group, right? Because this is about half-half, and this is 68%. So if I have a large enough populations, there must have been some people who, when presented with these three options, chose B, but when presented with the two options, chose A. Now, what do we see here? Now, is this choice rationalizable by a preference? Well, remember, for it to be rationalizable by a preference, and I made a video on this, it has to be the case that it satisfies property alpha. And property alpha said whenever there's some set, let's call this choice set X, and let's call it, well, little x, and let's call this choice set Y, it has to be the case that whenever the choice made in choice set Y was also available in choice set X, where this littler choice set is a proper subset of the bigger choice set. So whenever I made preferences satisfy property alpha, if for any choice made in a larger, if any choice made in the larger subset is available in the smaller subset, then it must be the case that it was also, this is wrong. If the choice of Y is available in the smaller choice set, so if the choice made in the larger subset, here B, was available in the smaller subset, which here in fact it is, it has to be the case that the choice made in the smaller subset is the same as the choice made in the larger subset. In other words, if they chose B in the larger subset but it was available in the smaller subset, they must have to also choose in the smaller subset, so long as if basically one subset's contained in the other. That was property alpha. If that holds for all choices, then the choice function satisfies property alpha. And that's a necessary condition for the choice function to be rationalizable. If it's rationalizable, it must satisfy property alpha, and we came up with a very simple proof of that. Rationalizable means that the choice made is always the most preferred element, or there has to be the case that we could come up with some preferences such that the choices made would always be the most preferred element. And basically, if it's the most preferred element, if B is the most preferred, if something is the most preferred element in a larger set and it's available in a smaller set, it also must be the most preferred element in a smaller set. That's a much quicker way of doing that long-winded proof I gave you. Okay, so here we see that clearly this does not meet property alpha because X is a proper subset of Y. Y just has this other alternative C, which turns out to be an irrelevant alternative. It wasn't chosen. And yet if someone had a choice function that mapped from A, B to A, and mapped from A, B, C to B, that just directly violates the property alpha. By adding an irrelevant alternative, I change the choice. By adding an alternative, I change the choice, but not to the thing that was added. Right? So the choice here is A, let's say, and the choice here is B. So we don't have this holding. So that was a violation of property alpha. Therefore, it cannot be rationalized by a set of preferences. Okay, but now we turn to, first of all, what could be going on here? Second of all, how would I describe this choice function in more general terms? Well, okay, as with some of the other funny examples, I'm going to leave out these information theoretic, sorry, I'm going to leave out choices, I'm going to leave out explanations that revolve around asymmetric information, that revolve around something that's not known, but when the larger choice set is presented, it's then known. You know, I can think of some plausible explanations here for why that might be the case. You know, I could think, okay, practically speaking, if I see this option C, you might tell me a little bit about how most people trade off ratings for megapixels, thus how much people value these two things. But we're not talking about that, okay? I'm just saying, let's suppose that these people were perfectly informed about the cameras and there was no asymmetric information issues here. One thing that's commonly claimed to be behind this asymmetric dominance or decoy effect or attraction effect is people say that people are particularly attracted to an option that is better than another option on all fronts. Okay, so here, A is better on the ratings front, but B is better on the megapixels front. In contrast, if I look at these three, okay, let's look at here. So as I said, compared to B, A is better on one front and worse on another front. But if I just simply compare B and C, I see that, okay, actually, or sorry, not B and C. Do I want to say B and C here? Yeah, B and C, 8.3. Sorry, this I wrote 4. This should have been 9 the whole time. I hope this didn't confuse you. Okay, B, it looks, but my 9 looked like a 4. I apologize. Okay, so if I look down here, this seems to be better, B seems to be better than C on both fronts, right? So 8.3 is obviously greater than 8.1 and 9 is greater than 7. So people seem to be attracted to an option, and I guess there's some evidence for this, but one thing that would be nice to do is to survey this evidence and look, how strong is the evidence? Do I find the settings in which this was found credible? Has it been replicated? Are there a lot of papers that say the same thing? Are there others that find the opposite, but they're being buried? Do I think people really had the incentives as described, et cetera, et cetera? Has it been presented in realistic settings? Okay, anyways, there seems to be, or at least I believe that there is a substantial amount of evidence that when people are presented choices and one choice, B, is dominating, quote unquote, is better than another choice, here choice C, along multiple fronts, people are particularly attracted to this choice and particularly unattracted to the other choice. Okay, so it might be that some people say, okay, I'm going to look for an option that is better than some other option in all categories, and that's going to be my preferred option. I can think of reasons why this might make sense given asymmetric information, to be honest. But if everything was known about these products, this doesn't seem to make a lot of sense. At least, okay, it might make sense. There's nothing wrong with choosing B, but it doesn't seem to make sense. At least it's not consistent with any single preference relation to choose B here and to choose A here, as it seems some people are doing. Right? Why should I prefer B over A when a third option is added that is not as good as, that is presumably not as good as well, certainly not as good as B, because people aren't choosing it. I didn't choose it. Okay, adding a third option I don't choose should not affect how I rank the two remaining options. Okay, now answering the question as I asked it to you, or part of the question, I said, how do I depict a choice function representing the attraction effect? So what I'm looking for is a choice function that would represent both this choice, perhaps, or both a choice of let's say, suppose I choose A here when I'm presented this choice set, and would have me choose B here when I'm presented this choice set, and perhaps that would carry over to other examples of what we might consider asymmetric dominance. Okay, so I want a formal way or a simple way of writing. I will choose an option if it's the option I will choose an option if it's better than some other option along all other characteristics. Otherwise, I don't know. Otherwise, maybe I choose the option that just plain gets the best rating. Okay, so how